Hello everyone, welcome to Basics e-learning. In lesson 7 video, I have explained how to sketch any given staircase signal from the given base pulse signal. All the questions that I have selected are from previous semester papers, and I have tried here to show step-by-step procedure by drawing signals. Please watch my previous videos to understand the concepts that I have used to solve these problems here. The first problem that I'm going to discuss in my video here is a continuous time signals x of t and g of t are shown here. Express x of t in terms of g of t. So the given signal g of t is a pulse signal with unit amplitude and time extended from -1 to 1. So this is your x of t signal, which is a staircase. So we have to express this staircase signal in terms of your g of t. That is, we have to construct x of t using g of t. So we have to perform any of the basic operations on this g of t, like time scaling or time shifting, and then construct this x of t. So here, whether the signal of g of t here is present in x of t or not. So if you closely observe this signal x of t, the pulse is present here. See this portion, right? So the signal is present, this part, the first layer of the signal is nothing but the pulse g of t, right? So this is layer 1, then layer 2, layer 3. So I am dividing the given problem into number of layers, 3 layers. So the first layer is nothing but -1 to 1, right? But with an amplitude of 3. So if you add step 3 to step 2 to step 1, then automatically the amplitude will become 3. So I'll just take g of t as my first layer, that is extended from -1 to 1 with an amplitude of 1. So this is g of t layer 1. Then layer 2 is the signal that is extended from 3 to 3. The limits of t are 3 to 3, -3 to 3 with an amplitude of 1, suppose say, because this is in the second layer. So that's why the amplitude became 2. It is extended from 1 to 2. So that's why it is amplitude is showing as 2 here in the picture. But totally 1 to 2 means total is amplitude is 1 only, right? So now signal g of t has an amplitude of 1 with the range of t as -1 to 1. Now I have to extend the signal to -3 to 3. So this is nothing but time scaling. So I have explained the time scaling property in my previous videos. I am leaving the link in the description box, so you can check for the property there. Now if g of t is extended when t is from -1 to 1, then to extend the signal from -3 to 3, t has to be divided by 3. So t by 3. So this we call it as time scaling property. So g of t is from -1 to 1. G of t by 3 is nothing but the same signal extended from -3 to 3. Right? So this is the signal I have. Then g of t by 4, that is nothing but this last step, the third step. This is second layer, and the third layer you have the signal, the same signal extended from -4 to 4. That range of t is -4 to 4 with an amplitude of 1, right? So if t has the range from -1 to 1, if you want to extend it from -4 to 4 means t has to get divided by 4, right? So this is also time scaling property. So I have divided g of t by 4 here, right? So g of t by 4, if I draw, the signal g of t is extended now from -4 to 4 with an amplitude of 1. So this is my layer 3. So to get the required signal x of t, I have to add up all these 3 layers. So see here, addition of these 3 is very simple. Just mark the amplitudes. Here at t is equal to -4, layer 1 has an amplitude of 0, layer 2 also have an amplitude of 0, Layer 3 has an amplitude 0 to 1. So that you add, you will get this 0 to 1, right? Now, at t is equal to minus 3, 0 here and then 1. Then here you have 1. So that you mark, right? So that is you have extended from 0 to 1. So that you can just extend the link, right? So just mark all the points of amplitudes here, then join. Similarly, at t is equal to minus 2, 1 plus 1, you have amplitude 2. So at t is equal to minus 2, I have an amplitude of 2. Just join. Then at t is equal to minus 1, I have 0 here. 0 to 1 extended. So amplitude is 3 here. 1 plus 1 plus 1, 3, right? So this is 3. At t is equal to minus 1, I have an amplitude of 3. So the pulse is extended here. Then at t is equal to 0, add all the amplitudes. Layer 1 has an amplitude of 1. Layer 2 has an amplitude of 1. Layer 3 also have an amplitude of 1. So 1 plus 1 plus 1, 3. Right? So similarly, you take the amplitudes at t is equal to 1, 2, 3, 4 for all the 3 signals. Mark the amplitudes on the final signal, join so that you will get your x of t staircase, right? So this is the procedure that how to construct your given staircase using this pulse signal. The second staircase problem that I am going to discuss here is, the given problem is like this. You are given with the signal g of t pulse and we have to construct this type of staircase x of t. Again, I am telling the same procedure. Step 1, we have to make sure whether the given signal g of t here present in x of t or not. So clearly if you see, g of t is a two-sided signal. That is, it is extended both on your left hand side and right hand side. But here the given x of t is only on your right hand side. So g of t is not present in x of t. So what to do? If you shift the signal g of t completely to your right hand side, then it is possible, right? So that means I'm using here time shift property. So I will shift the signal g of t 1 unit towards my right side. That means g of t becomes g of t minus 1 and the signal extends from 0 to 2 with an amplitude of 1. That means t has the range of 0 to 2. Instead, initially it has an amplitude of 1 minus 1 to 1. As I am taking here t minus 1, this minus 1 will go to the other side. Minus 1 plus 1 to 1 plus 1 means 0 to 2. The new range here is 0 to 2 for the signal g of t minus 1. Now check whether g of t minus 1 is present in x of t or not. So if you observe this x of t, you just divide this x of t into layers like previous problem. So if I divide this into layers, this my top layer, this is the second layer, 3 and layer 4. So this is 1, 2, 3, 4. So if you observe here 0 to 2, right? So the top layer is from t is from 0 to 1. Second layer is from 0 to 2, right? This is your second layer, 0 to 2. Third layer is from 0 to 3. Fourth layer is from 0 to 4. See, I will draw here. This is the first layer, 0 to 1, right? This part. This is the signal. Then second layer is this one. Third is this one, right? So this is your fourth layer. So second layer here it is matching, right? The second layer is from 0 to 2, right? Then 0 to 1 and 0 to 3, 0 to 4 are also similar kind of signals, but we have to scale the signal, right? So the shifted version of g of t is present instead of direct g of t. Now let us draw the layer 1. So layer 1 is like this, right? So with an amplitude of 1, time is limited from 0 to 1. So how to develop a signal of this type from g of t minus 1? Means here for g of t minus 1, t has the range from 0 to 2. Now I have to shrink the signal to 0 to 1. So for that I have to go with the time scaling method, right? So this is for g of t minus 1, right? So to do that, as I have divided the whole range by 2 to get my 0 to 1 range, so that I have to multiply t by the same 2 here, right? So the required signal is g of 2t minus 1. So g of 2t minus 1 I've drawn here. See, this is g of 2t minus 1 with an amplitude of 1 and the range is from 0 to 1. So from now onwards, consider this layer 1 as the base signal to construct the remaining layers. So layer 2 is automatically our g of t minus 1 only, that is 0 to 2 with an amplitude of 1. So this is done. Now coming to layer 3. Layer 3 is the signal with an amplitude of 1. Time limit is from 0 to 3. So for t minus 2t minus 1, g of 2t minus 1 if you are taking, it has the time limit from 0 to 1. Now I want the time limit from 0 to 3. So as I have multiplied the signal, multiplied the time range by 3 to get the new time range, I have to divide the t by 3 here. So that will be g of 2t by 3 minus 1. So the third layer is g of 2t by 3 minus 1 with an amplitude of 1 and the time limit is from 0 to 3. So with this, the third layer is also done here. Moving to the fourth layer, this is the fourth layer that you have with an amplitude of 1. Time scale is from 0 to 4. So taking the base signal as g of 2t minus 1, which has the range for t is 0 to 1. Now I need it for 0 to 4, means I am just multiplying the time range by 4. As I am multiplying the time range by 4, I have to scale the t such that you have to divide it t by 4, right? So g of 2t by 4 minus 1, that is nothing but g of t by 2 minus 1. So this signal is g of t by 2 minus 1. This is my layer 4. So with an amplitude of 1 and the time range is from 0 to 4. To get my x of t, I have to add all these signals in terms of g here. So if I add it up, at t is equal to 0 from layer 1, I have an amplitude of 1. At layer 2, 1. Layer 3, at t is equal to 0, 1. At layer 4 also 1. So 1 plus 1 plus 1 plus 1, 4. So at t is equal to 0 in the final signal, I have an amplitude of 4. At t is equal to 1, I have an amplitude dropping from 1 to 0, that you remember, for the layer 1. Second layer, third layer, fourth layer have amplitude of 1 respectively. So that is 3. So it's falling from 1, that is 4 to 3. Right? So just mark all the points like that. At t is equal to 2, this has 0 amplitude. It is 1 here, 1 here, 1 here. So 3. Right? Again, at t is equal to 3, 0 and 0. Here I have 1 and 1, 2. Right? So at t is equal to 4, 0, 0, 0, 1 I have. Right? So as all these are step signals, so join all the data points that you have marked with steps. So this is the required x of t staircase signal that I have drawn from g of t by taking the time shift and also time scaling. Remember, every time first you have to shift the signal, then only scaling should be done. Now they're asking you to express x of t in terms of g of t. So x of t can be written here as the combination or the summation of all these signals, that is g of 2t minus 1 plus g of t minus 1 plus g of 2t by 3 minus 1 plus g of t by 2 minus 1. So this is how I can write x of t in terms of g of t. Let us see one more problem here. So figure shows state case like signal x of t that may be viewed as a superposition of four rectangular pulses. Starting with the rectangular pulse g of t, construct this waveform and express x of t in terms of g of t. Right? So this is also like your previous problem only. So first we have to check whether this base signal g of t is present in x of t or not. Definitely no, because g of t is on both the sides, double-sided signal pulse. So you have both on left hand side and also on your right hand side. But here x of t, it is only on your right hand side. So first thing, we have to shift the signal g of t completely towards your right side. So if I shift the signal completely towards my right side, means I have to make a move of 1 unit towards the right, so that it will become g of t minus 1, right? So this will be g of t minus 1. So the range will be 0 to 2, because t has the range from minus 1 to 1. T minus 1 means this minus 1 you take it to the other side. Minus 1 plus 1, 2, 1 plus 1 means 0 to 2. So this is the base signal now I have to take. So what is that? G of t minus 1. So this is my g of t minus 1 extended from 0 to 2. Now check whether the signal is present in x of t or not. So like previous problem, if you divide this into number of layers, here the first step is like this, right? Only with 0 to 1. Next, second step is here you have that extended from to 1 to 2, right? So or otherwise you can take it as the pulses from the top layer if you're taking. So it is like this. Top layer is from 0 to 4. Then you just take it from 1 to 4. Then you take it from 2 to 4. Then the last you take it as 3 to 4. Then you invert the signal. Always start drawing the signals from your top layer. So that this top layer you have an amplitude of 4 here. Means it is from 0 to 4. You are keeping at the top. So that's why as you are adding up, so the amplitude, after adding up all the 4 layers, the amplitude will become 4. But initially you have to take it as amplitude of 1. So the first one you have to consider the top layer, that is nothing but this signal extended from 0 to 4 with an amplitude of 1. Now let us see. This is the signal 0 to 2, g of t minus 1. So to get this type of signal, that is the time shifted signal, from this time shifted signal g of t minus 1, I have to extend the signal. The time has to be scaled from 0 to 2 to 0 to 4. So what to do? T has the range from 0 to 2. Sorry, t minus 1 has the range from 0 to 2. Now I have to take it for 0 to 4. Means I am just multiplying this range by 2. So what to do? Just take this 2 to the other side, divide it, so that it will become t by 2 minus 1. So the signal here, the top layer here is g of t by 2 minus 1. So layer 1 is defined as g of t by 2 minus 1. Now we'll move to layer 2. So this is our layer 2 that is extended from 1 to 4. So take your g of t, which has the range from minus 1 to 1, right? So from this base signal, I have to draw the signal that has to extend from now 1 to 4, such that what will be the t value, right? So consider here 1 plus 4 is 5. This is the upper limit. 4 minus 1 is 3 here. So 5 by 3 times you have to upper limit minus lower limit, right? So 5 by 3 times you have to shift the signal first. That is g of t minus 5 by 3. Means what is the range of t now? If t has the range from minus 1 to 1, then g of t minus 5 by 3 means take 5 by 3 to the other side. So minus 1 plus 5 by 3 to 1 plus 5 by 3. Then how much it will be? Minus 3 plus 2. So it is 2 by 3. 3 plus 5, 8 by 3. So the signal is now extended from 2 by 3 to 8 by 3. Right? With an amplitude of 1. Now, but we need the signal from 1 to 4, not from 2 by 3 to 8 by 3. Now, the new range is 2 by 2 to 2 by 3 to 8 by 3 after shifting. But I need the range from 1 to 4. So, what to do? You have to scale the signal. First shift and then scale. The shifted amount, we have to find it out by using this addition and subtraction of the upper and lower limits. So, 4 plus 1 is 5. 4 minus 1 is 3. So, upper limit minus lower limits divided by lower limits. So, this much amount first you have to shift. So, g of t minus 5 by 3. So, find out the value of t here. New range of t. So, minus 1 to 1. Now, it will be minus 1 plus 5 by 3 to 1 plus 5 by 3. That is 2 by 3 to 8 by 3. After shifting, you have to scale this down to 1 to 4 range. So, to get the lower limit as 1 here, as I have 2 by 3, just multiply it by 3 by 2. Here also by 3 by 2. What you will get? This is 1 and this will be 4. Right? So, the time here has to be multiplied by 3 by 2. So, the signal will be g of 3t by 2 minus 5 by 3 for the second level. Right? So, for the second level, it is g of 3t by 2 minus 5 by 3. 3t by 2 minus 5 by 3 is the signal for level 2. Now, moving on to layer 3. Layer 3 is extended from here 2 to 4. This is my layer 3 here. See, this is 2 to 4. Now, we will do this. So, this is my g of t. If g of t has the range from, for g of t, t has the range from minus 1 to 1. Now, I need the signal range from 2 to 4. 2 to 4. Again, calculate the upper and lower limits. 4 plus 2 is 6. 4 minus 2 is 2. Right? So, this is 4 plus 2 and this is 4 minus 2. Now, you have to shift g of t by upper limit minus lower limit. Sum divided by difference. So, that is nothing but 3. 6 by 2 is 3. So, you have to take it g of t minus 3 first. So, draw it. If g of t has the range from minus 1 to 1, g of t minus 3 will have the range. Just add plus 3 to this range. So, minus 1 plus 3 to 1 plus 3. How much? So, 2 to 4. Yes, this is the required range. So, no need to scale down the signal. So, the third layer has the signal as g of t minus 3. So, the third layer we got just by shifting the signal by 3 units. Now, I will show you how to draw the last layer, the bottom one, fourth layer. Right? So, the fourth layer here you have extended from 3 to 4. Just 3 to 4. Again, write it. If g of t has the time range from minus 1 to 1, now I have to shrink the same signal from 3 to 4. So, for that, take the upper limit and lower limit. So, if you add 4 plus 3, you will get 7 and 4 minus 3 is 1. So, 7 divided by 1 times you have to shift the signal first. So, that is g of t minus 7. So, the new range of t will be how much? Check it out. Minus 1 plus 7 to 1 plus 7. So, minus 1 plus 7 is how much? 6 to 8. So, the new range of signal g of t minus 7 I am drawing here. This is g of t minus 7, which is extended from 6 to 8, right, with an amplitude of 1. But what is the range that we need? 3 to 4, not 6 to 8. So, to get 3 to 4, scale down the signal by 2, right? If you divide 6 by 2, you will get 3. 8 by 2, you will get 4. So, to scale down it by 2, as I am dividing the time range by 2, I have to multiply the signal here by 2, right? The signal, the time here by 2. That is g of 2t minus 7 is the required signal. Understand? First I have time shifted by 7 units and then scaled down by 2 units. So the top layer here I have is this one. So this I got by g of 2t minus 7, right? So after defining each layer, I have drawn all these signals here. So this is the top layer, first one, second, third and fourth. So now we have to add all these 4 signals to get the required staircase. So let us add it up. At t is equal to 0, the amplitude is 1 for layer 1, then 0 for all the 3 signals. So mark 1 here. Then at t is equal to 1, here for the top layer you have 1, then second layer also 1, third signal 0, fourth signal is also 0. So mark 2 here. Similarly, at t is equal to 2, 1 plus 1, 2 plus 1, 3. So at t is equal to 2, you have an amplitude of 3. At t is equal to 3, 1 plus 1 plus 1 plus 1. So 4. Drawn 4. At t is equal to 4, 1, 1, 1 and again 1, 4. So like this. After that it has dropped to 0. So I have marked here. So as all the signals are step signals only, without any fear, you can join all the points with step signal, right? So this is how we can develop a staircase signal using this g of t signal. So they have asked you to express x of t in terms of g of t. So this is x of t that you have constructed using all these shifted and scaled versions of g of t. So write it down. X of t is nothing but the summation of g of t by 2 minus 1 plus g of 2t by 3 minus 5 by 3 plus g of t minus 3 plus g of 2t minus 7. So this is how I can write x of t in terms of g of t. For more videos, please do like, share, subscribe to our channel. Let us know your suggestions and queries in the comment box. Thank you.